Assalamu alaikum. This is Asif Tazwar from Group 8. Me and my teammates will now describe you the line following robot made by our teams. My part is the world creation and the light and floor addition. Firstly, I created an environment and it came with a default background, so I didn't change anything much there. Then I created a wall and added some little bit bounding object, and it was type a wall. Then I just copied it 3 times and renamed them as wall 2, 3, and 4. Then I added a directional light so that our robot and the track and also the background are well lit and they have no extra shadows. Then I added a floor which is solid and changed its color, and I added the bounding object as a group. That's it for my part. My teammate will now describe about the robot creation. Thank you.
Hello, I am Sanjib Kumar. I have created the robot part of the line following robot project. I have used the same robot I created for the object detection project made earlier, except this time the geometry shapes are much smaller. There are several children nodes for this robot. The first three are distance sensors, which are used for detecting the line here and measuring the position and distance of the line from the robot. They are named DS right, DS left, and DS mid. The types of the sensors are infrared. These sensors are directed to the ground so that it can detect lines. Here you can see the distance sensors. They are all in red color. There are four hinge joints, also known as wheels, which are cylindrical in shape. Bounding object robot wheel has been used for the wheels, and physics has been added to each of the wheels as expected. I have used geometry shaped box for building our robot shape and used that as the bounding object for our robot. Moreover, I also added physics for real world simulation. Finally, I have attached this Python code for controller. Here you can see the robot is running smoothly following the line. Alright, thank you for watching.
Assalamu alaikum. My name is NAZMUL TANVIR. To add a line to our project, I'm going to use this Thinkercad software and I'm going to create a new design. It will take some time to create a blank page. Now I'm going to draw a line in this blank page. For this, I'm going to use this shape. Now I can create my own line as I want to do. After that, I'm going to make the height very low as it is possible, and making the color solid black. I can export this file now as a OBJ file, and I'm going to save this file to my PC. So to add this line to our project, I'm going to my Weaver software. So this is our project. We have built it, and I also added a line already. So for this line which I added, we have to go to the file and the import 3D model section. So as I already added the line, I am skipping this part, and in this line we have set it the value accordingly, different values for this line. So we have created the rotation values x, y, z. X is 1 and y 0, z 0, and angle 1.57. Also, we changed some scale value, which is x 0.024, y 0.024, and z 0.024, which will help our robot to complete its goal. Now, for discussing the PID implementation, my another teammate will discuss about it. Thank you.
Assalamu alaikum sir, I'm Monjurul Shokaromi. I'm going to describe the controller code of our robot. First of all, I have connected the controller code with our robot by adding this controller here, LFR PID. So I have taken time step of 32 and max speed of 5, which is the default speed of the four motors. Then here I have taken the potential constant as 1.5, integral constant at 0, and the differential constant of 0.3. So first I have connected the wheels, four wheels, basically the four motors, as wheel 1, wheel 2, wheel 3 as named in our robot part, and then initiate and then set the position as infinity and set the velocity as 0. Then I have connected the distance sensor part, distance sensor right, mid and left with our and enable the time step as 32 millisecond. Here I have started a loop. Then the we get value from the distance sensors, and from the distance sensor we calculate the errors if it's want to go right or left. This part is for if the robot wants to go forward. This part is for if the robot wants to go right, and this part is for robots wants to go left. This part is for if the robot wants to go left, and this part is for right. Here is the PID part. So PID implementation part. The PID implementation, here I have from these errors, it will detect the this this function. It will calculate from this function and send the um, send the value to the balance, and then it will decrease or increase the with our max speed, the and it will send to the four motors as power supply. Yeah, this the speed will set here for for motor speed. And here I will run this robot now. As you can see, for PID implementation, the robot is taking smoother turns, so because it has checked the error and calculated the calculated by the PID function, and it will decrement the error so that it can take smoother turn. Thank you.